Yes, good morning, everybody. Hope you guys are fine. This is CodePile Group 32, and we're here to present our research topic titled Interpretable Machine Learning for Student Performance Prediction in STEM Subjects in Ugandan Secondary Schools. And below are the authors of the above research topic. We have Wanyama Edgar Francis, and it's me talking. Then we have Mlongo Michael. I hope you are there, Mlongo Michael. And then we have Anembabazi Shina. Yes, she's around. Then we have Tibesigwa Duncan. Yeah, he's around. And the topic you're going to present is interpretable machine learning for students' performance in STEM subjects in Ugandan secondary schools. And by the term STEM, I mean science, technology, engineering, and mathematics. We see that the keywords for this research topic, we have interpretable machine learning, we have students' performance prediction, and we also have the STEM subjects. Yes. So I will take you through the contents of the presentation. We shall start with the introduction, then followed by the problem statement, followed by the related works, the research questions, then the objectives. Then we shall take you through the methodology of the research, then the experimental results, then the conclusions, then the future research direction, then the references, the acknowledgement, if any. So I would like to start from there by inviting my colleague, Nemba Shina, to take you through the introduction of this research.
Yes, good morning, everyone.
Morning.
So interpretable machine learning has gained increased attention in recent years as it enables the development of more transparent and accountable predictive models. Interpretable simply means degree to which human beings are able to comprehend factors. Then the interpretable machine learning is just the ability to which human beings can understand the machine learning models. So we have interpretable machine learning models. Interpretable machine learning has the potential to provide valuable insights into the factors that influence student performance, particularly in STEM subjects. By using interpretable machine learning techniques, it is possible to identify key predictors of student performance and inform interventions to improve outcomes for students in STEM subjects. STEM subjects, that is science, technology, engineering, and mathematics subjects. And with the interpretable machine learning techniques, teachers and the authorities who are responsible are able to use students' performance, their previous performances, or to use other factors, other criteria like their skills, to be able to tell how a student is going to perform in their future, let me say in their final examinations. For example, for UNEP, if we are to do for O-level students, and this will help them to know prior to the final examination whether the student needs extra help or the student is good to go. We shall explore the use of interpretable machine learning for student performance prediction in STEM subjects in Ugandan secondary schools, with a goal of improving access to education and opportunities for students in the subjects. Thank you.
Okay, welcome, Shina. Going through the problem statement, we see that the problem that our research is trying to address is the lack of interpretable machine learning models for student performance prediction in STEM subjects in Ugandan secondary schools. And we ask ourselves, why and how is it a problem? It is a problem because there exists some other methods for predicting students' performance. And we see that these methods do not accurately predict students' performance and are not transparent to predict students' performance, meaning that the use of interpretable machine learning models will be very, very relevant for this research because it provides transparent predictions. And we also see that these traditional methods are often subjective and may not accurately predict future success for students. And we want to discover that the use of machine learning in education is still relatively new in Uganda, And this means that there is lack of understanding about this topic, and also limited experience, or actually totally no expertise in this area. And we see that to address the above gap, our research suggests to provide students with the necessary resources such that they can actually know their performance, and also see that to support the implementation of the interpretable machine learning models for predicting students' performance in these Ugandan secondary schools. Further on, as I go to the related works, we see that the paper, Interpretable Machine Learning for Students' Performance Prediction in Higher Education by Gama 2014, see that this study used decision tree and rule-based models to predict students' performance in a Brazilian university, and found that these interpretable machine learning models were able to achieve high accuracy and actually were more understandable than the complex models. And also the other related works, we see that the paper or the research topic predicting students' performance, student success in higher education using interpretable machine learning models by SR Constiatis in 2006, we see that this study used a number of interpretable machine learning models, including decision trees, rule-based models, and linear regression to predict students' success in a Greek university. You see that these authors actually found out that these models were able to achieve good performance and were able to provide insights into the factors that influence students' success. Yes. When we go further on to the research questions, these are the questions that actually driving our research. These are the ones that give us the reasons why we are making our research. And we see that one of the research questions to how effective is a machine learning model at predicting students' performance in STEM subjects in Ugandan secondary schools. Then the next is, what is the potential impact of using the machine learning model on improving students' performance in STEM subjects in Ugandan secondary school? Like what impact does it have on predicting students' performance? Then the next is, what are the challenges and limitations of using interpretable machine learning for student performance prediction in STEM subjects in Ugandan secondary schools, and how can we overcome those challenges? Then the other research question driving our research is, what is the potential for using interpretable machine learning to support decision making and intervention planning in the context of education, STEM education in Ugandan secondary schools? So the above are the research questions that are driving our research. So I would like to actually call upon my colleague, Mlongo Michael, to take us through the research questions. Mlongo Michael, you're welcome. You're welcome. Mlongo Michael, are you there? Mlongo Michael? I think he has network issues, so I beg to continue from there. Research objectives, these are the ones that give us the reasons as to why we are carrying out our research. And one of the main objectives, to develop and evaluate a machine learning model that can actually predict students' performance in the STEM subjects in Ugandan secondary schools. Then the next is to assess the potential impact of machine learning model on improving students' performance in STEM subjects in Ugandan secondary schools. Then the next is to identify potential challenges and limitations of using interpretable machine learning for student performance prediction in STEM subjects in Ugandan secondary schools and suggest the ways to overcome them. Then the last objective is to explore the potential for using interpretable machine learning to support decision making and intervention planning in the context of STEM education in Ugandan secondary schools. So these are actually the questions, the answers to the questions. Yeah, these are the objectives, the ones that give us the actual answers to the research questions that are driving our research. Then to go further on with the methodology, this is the approach that we are actually planning to use to come up with a model. And one of them is data collection, whereby we have collected some data and we're actually still in the process of collecting the data. Yeah, and we are also getting some data some data sets from online tools that we shall be able to do what to use. And then the next stage is data processing. This includes data cleaning, feature selection, and data transformation, whereby data cleaning, we see that we shall be able to detect and correct errors in the data, and also remove inconsistencies in data such that we make it accurate. And this will help us make accurate accurate predictions. Then the next stage is feature selection, whereby we see that our model is actually going to be having a lot of features because there are a lot of factors that actually influence students' performance. So we shall pick the relevant features from the very many that we shall use to reduce performance of students. Then data transformation. This one includes changing data from one form to another. So we see that our data set actually will be having both numerical data and categorical data. But in order to deal with categorical data, we need to actually transform it into numerical data by simply encoding it into numerical data, because it is very easy to deal with when it's in numerical form. Then the next stage is model development, whereby we shall split the data into the training set and the testing set, and we shall apply machine learning algorithms on the testing set. Then later we shall apply machine learning algorithms on the training set. Then we shall later validate the model, and later apply the interpretability methods that will give us accurate predictions. Then I shall evaluate the model using the testing set by using the various evaluation metrics such as recall, such as precision and accuracy. Yes. Then further on, we shall have to embed this model into a web application, and we shall later on test the web application to see whether it is giving us accurate predictions. If it will give us accurate predictions, then we shall deploy it. But if it will not be giving us, we shall have to go back and see where the problem is, such that we clarify the errors. Then to go further on with the expected results and contributions, we see that our research will be able to be accurate in predicting students' performance compared to other models that are currently existing. And we see that it will be able to help reduce number of false positives and false negatives. Then we see that increased transparency. We see that the machine learning models will be able to provide insights into factors that influence students' performance, which can help educators understand challenges that students face. Then when we go on to improve fairness, see that by using interpretable machine learning, bias on predicting students' performance will be able to be reduced, which will in turn ensure that all students are given equal opportunities regardless of their background. Then the next result, you see that there will be improved decision making, whereby machine learning models will be able to make insights into factors that influence students' performance, and this will help. This is where the educators and policymakers will base to make their predictions. When we go to the next slide, I would like to welcome my colleague Chiwesco Duncan to take you from there. Thank you.
All right, this is Chiwesco Duncan. It's important to consider interpretable machine learning when predicting students' performance, as understanding the factors that contribute to student success can help the educators and policymakers make informed decisions on how to support and intervene for the struggling students. The future works of our research, we intend to extend the scope of our research. Currently, we are focused in Uganda, and we intend to expand it to the rest of East African countries and Africa as a whole. For the acknowledgement, I would like to thank the Almighty who has given us the life, who has given us the knowledge to make this research. And then also we thank our supervisor, Mr. Galwango Marvin, for his guidance and tireless efforts he has put in to ensure that we produce quality work in this research. Thank you for listening.